Alright, so today what we want to look at is the concept of the reference angle. A reference angle is what is going to allow us to find trig functions of any angle, not just using SOHCAHTOA to do the acute angles, the angles in the first quadrant. Using a reference angle, we'll be able to find trig functions of angles in the second, third, or fourth quadrants as well. Okay? Or even angles from rotations, full rotations, or negative angles, or whatever. We'll identify a reference angle that'll allow us to find the trig functions. Okay? So let's talk about what a reference angle is, first of all, and then illustrate it a few times, and then we'll do a couple of different kinds of problems using them, so you can see kind of some of the variation of what we can do with these. Alright, so first of all, the definition says, let theta be an angle in standard position. Its reference angle, in green on these three, is the acute angle, using the notation theta prime, formed by the terminal side in red and the horizontal axis there in blue. Kind of color-coded it for you so you could pair the terms with what they are in the diagrams. Okay? So, the reference angles here are in green. Notice a couple of things here. First of all, the reference angle is going to be acute. Okay? It's acute.
No matter what?
No matter what. Okay? It's acute. Now, you'll see here the reference angle in green falls between the terminal sides. Notice here the terminal sides are in red. Okay? And the horizontal axis. Now, that word acute I already highlighted is important. Because if you notice here, if I look at the horizontal axis, there's actually two different angles I could make with my terminal side and my horizontal axis. I could make this reference angle that I've already highlighted, or I could make theta in this case. I always want the acute one. Alright? So that's why you've seen I've only highlighted one side on each of these, okay? Alright? So, I want to just give you an example of each of these. We'll even use examples from our unit circle, and I'm intentionally going to use radians just to give you guys some more practice with this. Okay? Now, let's say that our angle theta is, let's say 5 pi over 6. Okay? Angle theta is 5 pi over 6. Well, you guys know that if I go all the way over to the negative x-axis, that's going to be pi. So our reference angle, our reference angle needs to be pi over 6. How much more? If I have 5/6 of a full pi, I need another 1/6 of a pi to make it a whole pi. Okay? So my reference angle there is pi over 6. Okay? Here in the third quadrant, again, you'll notice the angle is between the terminal side and that negative x-axis, okay, which is pi. Let's say that in this case, theta is 5 pi over 4. Okay? So in this case, if it's pi to get to the x-axis, and I want to go all the way to 5 pi over 4, I want to figure out how much more I would need, right?
Yeah.
So that would be, not the 5, just pi over 4, okay? Pi plus pi over 4 will give me 5 pi over 4. Okay. All right, so that's our third quadrant. The fourth quadrant, let's say this one, theta is 5 pi over 3. Okay? 5 pi over 3. In this case, however, we're going all the way to 2 pi. Notice it's between 2 pi and the terminal side this time. Okay? So how much more of an angle do we need for our reference angle in this case? Yeah, it'd be pi over 3. We have 5 pi over 3 plus another pi over 3 would be 2 pi. Okay? Now, here's the thing. You guys figured that out pretty easily if you just thought about it compared to either the pi or the 2 pi. And I would recommend doing that. You'll notice there are little formulas down here that you can see, you know, pi minus theta in the second quadrant, theta minus pi in the third, 2 pi minus theta in the fourth quadrant, okay? You don't need to memorize those if you just think, okay? Visualize it and think, and you can figure out these reference angles, okay?
I got my unit circle down to 4 minutes, man. I'm ready.
You got it? Awesome. Good. All right, now one other thing I want you to see, and then we're going to talk about what good this is, all right? Notice here 11 pi over 6. 11 pi over 6 is in the fourth quadrant. The reference angle here is pi over 6. We've seen that reference angle before, haven't we?
Yeah.
Okay?
Negative
At
2 from 1/2.
5 pi over 6, right? So does anyone want to venture a guess at a pattern here?
Yeah, man. You're going by your unit circle.
Well, the unit circle does have reference angles on it. How do look at the reference angles? They're both pi over 6.
Oh, they're one less than the total amount of pi necessary to complete the full unit circle. I don't know if you know what I mean by
In that case, yeah. In this, it's one less than the full pi.
What do you want from me, man? I don't know.
What do you notice about the angles?
They're all in the middle.
Cute angles, all cute, bro.
What's 45?
They're not 45s. These are
Pi over the denominator.
30s. What?
It's all pi over the denominator.
Pi over the denominator. You see that? Hey guys, listen. I know radians can be a pain, but when it comes to reference angles, radians are really easy. Because on your unit circle, if you see anything pi over 4, guess what your reference angle is? Pi over 4. Okay? If you see any of the things where it's something pi over 6, your reference angle is going to be pi over 6. Okay? So that's one thing that's really nice. We'll see even more of that in a minute. So what? Okay? What's the significance here? What's the big deal? Why do we care about reference angles? This is why right here. And this is a really powerful principle that we need to learn. If two angles have the same reference angle, then their trig functions will either have the same value or they'll just be the opposite value. Okay? So if I have pi over 6, and the sine of pi over 6 is?
6 over pi. Or 6, wait.
The sine of pi over 6?
And
1/2.
1/2. There we go, 1/2. Sine of pi over 6 is 1/2. Then if I have 5 pi over 6, 7 pi over 6, or 11 pi over 6, or even 13 pi over 6, or a negative pi over 6, or a negative 11 pi over 6, guess what sine of those is? It's one of two things.
1/2.
It's either a half or
Negative.
negative 1/2.
Exactly.
And we're going to look in a minute at how to tell whether it's positive or negative. But that's what's so powerful about this. Okay?
6 minutes.
So, let's look at our unit circle. on our unit circle, we can see what we just said, alright? Let's take a quick look at this here. If I look at that pi over 6, since we've been dealing with pi over 6, the sign, remember, is your y coordinate, okay? There's the 1/2. Over here at 5 pi over 6, the y coordinate is 1/2. Here at 7 pi over 6, the y coordinate is negative 1/2. And over here at 11 pi over 6, it's negative 1/2. Okay? Now, how come it's negative some places and positive other places?
So you're going
Two
negative
different
in
quadrants.
X, yeah.
You're reflecting across the X and Y axis.
Of course.
Okay, different quadrants are reflected across the x-axis. When we reflect across the x-axis, it makes them negative, right? It makes the y coordinates negative. So guess what? I can say that in my first and second quadrant, sign is going to be
Positive.
positive. I have a positive sign, and I have a positive sign. However, in my third and fourth quadrants, I know that sign is
Negative.
negative.
Ooh, it's gonna be the opposite from cosine. It's gonna be like 2 and 3 are negative.
Okay, well, let's think about cosine. You're saying 2 and 3 are negative?
Yeah, and one.
Because why?
Because you're reflected across the y-axis. Because you're putting you're making negative your y when you plug it into the equation, which makes 2 and 3. Because that's the y-axis.
Okay.
Up and down. Oh, I learned about this. I'm going to connect this to world history because you're going up and down, and then when you're going X, you're going east and west sort of thing. So like.
So good.
Okay.
Two
So hang on. So cosine is which coordinate?
Y. Oh, square root of 3 over 2.
No. Cosine is what coordinate? X or Y?
X.
It's the X, alright?
Ah,
Brain's going faster than our mouth. That's okay.
that's the point.
Our mouth is going faster than the brain. I think that was it. Alright, so if cosine is the x coordinate, we just have to look at where is the x coordinate going to be negative. And you were right. The second quadrant, cosine is going to be negative. And in the third quadrant, cosine is going to be negative. However, look at where the x coordinates are positive. X is positive here in the first quadrant and in the fourth quadrant. Okay?
It's really easy.
Now, here comes the one you got to think about. Tangent. Tangent equals
Sine over cosine.
sine over cosine, right?
So if it's wherever, the sine is always going to. Oh wait.
So it's your first
So-
and
Oh,
third
it's
that are
yeah,
gonna be
first and
positive.
third, 2 and 4. Yeah.
Okay, so yeah, look, if I have a positive over a positive, that's going to give me a positive. And if I have a negative over a negative, that's going to give me a positive. So good, the tangent is in the first and third quadrant, positive, but it's negative in the second and fourth quadrants. Okay? Now, let's generalize all of this into something that's easy to remember. Okay?
Is there a theorem for this?
Not a theorem, it's more just a nice acrostic for us to learn. Okay? So,
1 and 4 are
in the first quadrant, all of our trig functions are positive. In the second quadrant, what's positive?
Sine and then
Why?
Sine. In the third quadrant, what's positive?
tangent.
Tangent. And in the fourth quadrant, what's positive?
Cosine.
Cosine.
So that's what the picture
So-
of the meaning. Okay.
Exactly. This right here, I honestly, I always write this up in the little corner of my paper just so I remember it.
Cats.
Okay? Well, maybe. Actually, the easier way, that goes in the same order, there's a lot of different ways you could do it,
SAT.
but to go in the same order as your quadrants, you just remember that all students take calculus,
Oh, I said.
and it'll be easy to remember, okay? All students take calculus.
Isn't calculus technically like a 12th grade? Pre-calc like technically a 12th grade course? No,
It depends. So that's an easy way to remember this. And that's why, once you get the hang of reference angles and all students take calculus, if you know this much of your unit circle, you're good to go. Okay?
True those.
So,
Where your signs are.
now let's do a couple of different examples how we can use this in order to figure a bunch of different stuff out. Okay? Let's start, first of all, here. We did this a little bit already where we were finding the value of all 6 trig functions. However, we were kind of stuck in the first quadrant because we have to use a right triangle. Okay? So you'll notice here, I've got this angle theta, and I don't know what exactly the measure of that angle is, but I know it ends over here in the third quadrant. Okay?
Got your sine, your cosine already.
So, well, here's what we have to figure out, okay? If I'm going to do this, I can use my reference angle, and I'll call it theta prime like the book does. I'm going to use that reference angle, and I know that if I find the sine, cosine, and tangent of that in the little right triangle that I've drawn now, all I have to do is apply the fact that I'm in the third quadrant to figure out my signs, positives and negatives, and I'll have all my answers, okay? So let's do that part first. I'm in the third quadrant, so what's positive?
Tangent.
Tangent, and if tangent is positive, is anything else positive?
Nope.
No.
Out of all 6?
Oh, cotangent.
Cotangent will be, okay? Taking the reciprocal won't change the positive or negative here. It only changes the value, okay? So if those are positive, that means sine and cosine are both negative. If sine's negative, cosecant is
Negative.
negative. And if cosine is negative, secant is negative. Okay? So all the signs are taken care of, and the nice thing about it is now I can just think about my right triangle and not even worry about the negatives anymore. Okay? So, let's figure this out. We've got 8, 15, and you know your Pythagorean triple, 8, 15,
8 squared plus 15 squared.
17, yeah, okay. Yeah, by the way, I hope you know 3, 4, 5, but you also have 8, 15, 17, 5, 12, 13, and 7, 24, 25. Those are 4 common Pythagorean triples. If you keep those in mind, that might help you. We like our triples, especially if you're taking the SAT or ACT, they show up a lot. So, alright. Now that we know all 3 sides of our right triangle though, we can use SOHCAHTOA, and then flip them all, and we've got our 6 trig functions. Okay? So let's do that. What's the sine?
8, negative 8. Oh wait.
No.
Negative 15. Okay.
Negative 15
Over 17.
over 17. Okay? Negative 15 over 17. What's cosine of theta?
Negative 8 over 17.
Yeah. Negative 8/17. Adjacent over hypotenuse. How about tangent?
15 negative 8s. Or negative 15 8s. Oh wait,
Negative-
15 8s.
Yeah, negative 15 over negative 8, so it's a positive 15 over 8.
I did not say
Okay.
negative 15.
And then just reciprocals.
Now you just have to flip them. So it's negative 17 over 15, negative 17 over 8, and 8 over 15. Okay? Well, we're not worried about getting what theta actually equals yet. We will do that in the future, but we're not going to worry about that yet. Okay? That's a good question, though. Now, notice in this case, we weren't getting values that were from our unit circle, and that's okay. All right? It doesn't always have to be from the unit circle. This one, however, I actually can use the unit circle for. Can someone tell me why I could use the unit circle for this one?
Not sure.
Because it's just twice the unit circle. So.
Is it because that
Oh,
bottom
No.
because
is
this is
white?
45 degrees.
How do you know it's 45 degrees?
Because it's 2, 2.
Yes, look, we've got an isosceles right triangle, right? -2 and 2. That's isosceles right triangle. Okay, if you want, the hypotenuse would be 2 root 2. But the fact of the matter is, if we've got a 45-degree reference angle, or pi over 4, I can now use the point on the unit circle. Okay? I'm in the second quadrant, so I know sine's positive, and cosine and tangent are both negative, which means I know these signs over here. So now, at the 45, what does sine equal?
2 square root over 2.
Yeah, there he goes. Root 2 over 2. How about cosine?
Root 2 over 2.
Negative.
Good. In this case, it's a negative root 2 over 2 in the second quadrant. How about tangent?
Negative 1.
-1. Okay. Remember, it's sine divided by cosine, and sine and cosine are both root 2 over 2, but there's a negative, so it's -1. Okay. So, what's cotangent?
2 times 2 over. Wait, 2
2
times the
square
square root
root.
of 2 over 2, right?
2 square root.
Cotangent.
Actually,
Cotangent.
Then negative 1.
-1. Sorry, I was starting with the easier one first. What you said, though, was right. You were thinking of cosecant, right?
Yeah.
Okay. So you flip that 2 over root 2. You multiply it by root 2 over root 2.
let's use
2
And that's 2 root 2 over 2, which is root 2. So the cosecant and the secant both equal root 2. Any questions here? All right. Let's look at some other stuff that we can do with this. Okay? One of the things I love about this unit, and I love about trig, is that a lot of this stuff is just kind of like puzzles you got to figure out. Okay? Let's look at another thing here. Where am I? Okay? Where am I? In what quadrant is theta if we know this? Okay?
Quadrant 3.
Okay.
So, in the first case, I know that sine is negative and cosine is negative. So where are sine and cosine both negative?
Quadrant 3.
3.
Yeah. Yeah, if you think about all students take calculus, think about it this way. Sine is negative here and here. Cosine is negative here and here. So, I must be in the third quadrant. That wasn't as useful as I thought it was going to be. I can't get rid of it now. There we go. All right, so this is quadrant 3. If the secant is positive, what do I know?
Sine is positive.
Not sine, cosine. I have a positive cosine, and if cotangent's negative, I know I have a negative tangent, right?
Yeah.
So where on my quadrants do I have a positive cosine and a negative tangent?
Fourth one.
In the fourth quadrant, okay? I have a positive cosine here and here, I have a negative tangent here and here, so I must be in the fourth quadrant there. Okay? See how these are just kind of puzzles that you can figure out?
Yes.
Alright, so how about 15? Our cotangent's positive and cosine is positive. Where are we? 1, that's right. Good. How about tangent's positive but cosecant's negative?
Third.
Okay, that'd be the third, because if cosecant's negative, that means sine is negative. So that leaves us with the third quadrant. Okay? Alright, other kind. We're not going to do all of these, but let's do 19 here. Okay? 19. Our tangent, doing this one here, tangent is negative 15/8. And it says sine is negative. So if tangent's negative 15/8 and sine is negative, where are we?
If they're both negative.
Tangent's negative and cosine's negative.
Negative on cosine.
ASTC, you're in the fourth quadrant.
Fourth quadrant, okay? I know I'm in quadrant 4, so now I know that sine's negative, cosine's positive, and I know all the signs over here too. Okay? Again, figure out what quadrant you're in and fill in those signs first. That'll really help. Okay? So, what's the easiest thing to find first?
CK? I'm sorry,
Cotangent.
Cotangent, alright, so that's a negative
8 or 15.
8 over 15. And then, let's see, if tangent, according to SOHCAHTOA, if I've got theta here, tangent's opposite over adjacent, what's my hypotenuse? 17. Ah, there's that triple again. Okay. So now I just have to use SOHCAHTOA and then flip them, and I get the rest. So what's sine?
15 over 17.
Good, a negative 15 over 17. Cosine is
8 over 17.
8 over 17. And then I flip them. 17 over 15 and 17 over 8. And we've got all 6 trig functions. Okay, everyone with us?
Yes.
All right. Now, we've got to do 23. 23 is fun. All right. You got to think about this one here.
Undefined.
Okay? Cotangent's undefined. All right? Well, wait. Tangent's the reciprocal of cotangent. So what's the reciprocal of something undefined?
Undefined.
0
Defined.
over something.
Yes. All right. In order to be undefined, you have to have something divided by 0, right? So if I flip that, I have 0 over something, right?
Yeah.
Which equals
Yeah.
0, okay? That's 0 for tangent.
Cool. So that's
So
positive
the
or
bus
negative.
cosine and then sine and everything else also equals 0
So,
because it'd be on like the 360 line.
Well, let's think about it. Okay, tangent is going to be 0 at 360 or at
180.
180. And that's because tangent equals what over what?
Sine over cosine.
Sine over cosine. So let's think about that.
Oh, then cosine over sine has to equal undefined, and sine over cosine has to equal 0 over something, right?
Yeah.
So
So
we got sine. Sine is 0.
sine is 0. That's exactly right, because it has to be 0 over cosine.
Yeah.
Now, this is where you got to use your unit circle a bit. Notice the angle that we were given. We're in which 2 quadrants?
Ooh,
The
1 and 2.
second and third.
Yeah, pi over 2 to 3 pi over 2. We're somewhere over here. Okay, so tell me, where does sine equal -1, or where does sine equal 0?
180.
At 180 exactly. Okay, and what point is that?
1 0. Negative 1 0.
-1, 0. So what's the cosine?
Negative 1.
And what's the secant?
Negative 1.
-1. And by the way, what's the cosecant?
Undefined.
Undefined. Alright? That's a cool one.
Nope, that's just evil.
Okay? That's just evil.
So undefined, why did we choose this tangent first? Tangent divided
How do we know tangent is 0? Well, just because it's undefined, the thing that makes it undefined is that we're dividing by 0. Okay, so we know we've got some fraction with 0 in the denominator. So if we flip it, the 0 will be in the numerator, and that makes it equal 0. Okay? It's kind of like, you guys remember when you found perpendicular lines, you had to do opposite reciprocal slopes?
Yeah, we did do that.
And the vertical lines had an undefined slope. But perpendicular to that was a 0 slope. Horizontal lines. So 0 and undefined are reciprocals of each other. Okay? Alright. Let's do one real quick here like this. Let's think about these. Notice not all of these are within one rotation or even positive angles. Okay? So for example, let's do the radian one. 11 pi over 5. Where are we?
It's it passed
So fourth-
one circle, then
fourth part.
to the first, then
You're right, Winnie. Yeah, it passes one full circle, and it's in that first quadrant.
Wait, how do we know that it passed through?
Well, because 11/5 is 2 1/5, right?
Oh, okay.
So 2 pi would be the full circle,
Right.
so that means our reference angle's what?
pi over
One,
5.
yeah.
Pi over 5, yeah. Pi over 5. Okay? Another thing that can be a little tricky is when our radians are given as decimals rather than pies. Okay?
Yeah.
Pi is what as a decimal?
3.14.
Thank you. Somebody, we know that. So 3.14. What's pi over 2 then, approximately?
1.5.
5 something.
1.57 about, okay, 1.57 something. Alright, so if I'm going at negative 1.8,
You're in quadrant 2.
where am I? Negative 1.8.
Oh,
So,
that's annoying.
like go down, yeah.
Quadrant 3.
Quadrant 3, okay? Because I'm past negative 1.57, I'm in negative 1.8. Alright, so the reference angle here,
0.37.
it's going to be positive,
Oh, right.
but
2 pi minus, oh sorry, 3.14 minus 1.
there we go, good. 3.14 minus the 1.8.
Yeah. Oh, so that'll just give you that makes sense.
Yeah, it'll be 1.34 radians. Okay? And this is radians. Okay? Alright? Lots of cool stuff you could do with these reference angles. Lots of application here, okay?
Wait, is that
Check
that
right.
angle, right?